So you must be working on the MATLAB, right? Okay. So this is matplotlib,
Okay.
matplot library. Basically, you do the same thing, but with Python. And it is much easier because you're already handling the data at one place, right? You're
Hmm.
handling processing the data at one place, so it makes it easier to utilize on whatever you have on whatever pre-processing that you have already done.
And then I just feel foolish now that I used the wrong thing. Sorry about that.
No,
Man.
no worries. That's totally fine. At least you you tried to start something, right? That's the best thing. No worries.
Oh gosh.
Okay. So first of all, let's talk about like the pain points, then we can go further in helping you with the pain points. So with respect to module one, we will be talking about portfolio, program, and projects, right?
Hmm.
So, like, I want to understand what at what level do you manage the projects? Do you manage a lot of projects at a time, or do you manage some program which consists of a lot of projects?
Yeah, like 4 to 5 projects is
Four to
what I'll
five
be
projects.
managing. Yeah, before at the same time, yes.
Okay. And what is your pain point actually? Like in day-to-day life, what is the most redundant process that you have to do daily, which can be automated or which can save some time if it was done by somebody else?
Statistics.
Statistics. Okay.
Hmm.
And
And so there's usually just a combination to show kind of percentages of what has been
mm-hmm.
completed, what's in progress, right? And things that are like not started. So I kind of show those in relationship to milestones against like the project, right? So to show where we are, right? So
Okay, as you also mentioned that you are working with the Scrum Master is also reporting to you, right?
yeah, sometimes I run Scrum too, so I own that
Okay.
responsibility too. So
Mhm. So that's definitely a total waste of time if you have to do it manually again and again, right?
yes,
And keeping a track of each and every task which is completed or not. Are you
that is
comfortable
correct.
with Gantt charts or what?
Yes, I do. I am familiar with Gantt charts.
Uh-huh. That's
Um,
good.
Another thing that I kind of keep track of is metrics for like some agile related metrics to cycle time, how long things spend in a certain duration, so that way I can make uh recommendations on how to improve things for the team, right?
Mm-hmm.
So if, for instance, I'm noticing that changes are spending a longer time like in QA, I can
Mm-hmm.
then say, all right, cool, we have a bottleneck here. What are some of the things that we can do to improve it? And I may start digging into taking a look at estimates and, where we estimated time against
Mm-hmm.
completing tasks in QA that are getting hung up, and
Yeah.
then suggesting and making some improvements for that area. So that's another thing because I'm grabbing like a whole bunch of work items and providing like data against those work items for statuses, how many we have here, how many are tagged appropriately. Those kind of things are a definite pain point for
Yeah.
myself.
So as I can understand, you want a very streamlined process which can reduce your manual effort to a greater extent, right? And it can help you give you insights about the
Hmm.
pending task, about the bottlenecks, so that you can plan
Hmm.
accordingly.
That's correct.
And which board do you use to manage all these?
Let's go.
Zira or Microsoft Azure?
No, I'm using Salesforce. The
Oh,
Jira stuff, like
yeah,
dashboarding, is
yeah,
cool. Like
almost
I could
all the
easily like
platforms are same.
dashboard those things, right, to
Yeah.
give me those metrics. But in Salesforce, because the different teams have different attributes and all the work items are the same
Mm-hmm.
for what's mandatory and what's not mandatory, like
Mm-hmm.
streamlining that stuff has been like a nightmare. So I mainly have to go in and pull the reports, take a look at the data 5, 10, 15 times to make sure that everything is clean. And then I have
Mm-hmm.
some macros or whatever that I try to write to help, but like it's just not fun. That's all. It's just not fun at all, and it's very repetitive. And getting metrics out, is something that using Jira for one project takes me like 15 minutes, right? And whenever it comes to like using Salesforce for these Salesforce projects, it takes
Yeah.
forever, and I hate
I
it.
totally understand the pain now. I can understand it quite clear because it is just like moving. PMO is just like the traffic control sort of thing. Without it,
Mhm.
everyone is driving, but it is total chaos.
hmm Yeah, so and so what happens often is that you'll have stakeholders that want kind of a just-in-time metric, right? Sometimes for cost or whatever. So pulling up and getting where we are with the budget, right?
Hmm.
And what we're forecasting in our actuals, pulling that information too is sometimes challenging. So
So you are also managing the budget as well.
yes.
Okay. And how are you tracking the budget based on the hours spent and what is the rate or the like how?
Hours and rate.
Okay. Okay. So do you also do the planning in dividing the task or dividing the project into multiple phases?
I guess I do. But with that, I get help from the the tech team. I can't make those things up,
Yeah,
right?
definitely,
When I
definitely.
create my, I can after I create my Wibis or whatever, you know, doing some of the sequencing on what will happen, building out like you know. I
Yeah.
call them like placeholder, like user stories that get filled in and groomed at a later time, but just so that we can
Hmm.
understand what we're trying to get accomplished at a high level, like doing
Hmm.
some of those things. And um, those are
Right.
other tasks that I do.
So we will first, I'll try to first clear down some mental models so that it is easier for both of us to stick to one vocabulary as well as the concepts, right?
Okay, that's fine.
Mhm. So that whenever you are having a conversation, it's not a buzzword to you. You are already knowing about the word and how does that work.
Okay,
Cool.
okay, that's fine.
So what do you understand by AI?
What do I understand about AI?
Yeah.
I mean, we've had that one day that we spent, right?
Yeah.
So I got to learn a little bit about AI, right?
Mhm.
And my first like learnings with AI now is, deep learning and machine learning, right? And were some of the definitions and terms that I walked
Yeah.
away with, right? And and the thing with deep learning is it didn't have like it has like non-linear relationships is what was explained. So it
Hmm.
can have multiple variables and layers to it, right?
Yeah.
And what I learned about machine learning, right? We went through an example, right, where these for machine learning, the models are more linear, right? So
Yeah.
just like true or false type scenarios is
That's
that's the
totally
way,
correct.
right? Yeah. Moreover than that, the last bit of information that I kind of recall here is what we were covering in terms of vector and embeddings, and these are the assignments are numeric representation for words, so it allows the AI to be able to utilize the use
Yeah.
of words by plotting them on a graph, right? So there are
Mhm.
coordinates for each, um, here, and uh, something that was mentioned previously was ADA embedding, which I think it has a
Yeah.
default of 1536 like dimensions, and we went
That's
over
great.
a little.
Great.
Some of the tools
Okay.
that are
So,
used there, right, is these are the
mhm.
tools that I kind of copied down, and I was like, oh, I kind of want to dig in a little bit to understand the tools a little better. I saw that you use Seaborn, right? I saw that a tool that you also were using that I started to play around with a little bit was Google Collab.
Mm-hmm.
And just briefly, I just captured some of the names of things like Kaggle, which I've never used before.
Okay.
And then I saw TensorFlow was another tool that I copied, as well as Hugging Face, which was new to me. And I totally screwed up by capturing MATLAB.
Okay.
But
No worries. No worries. That's totally
but
fine. But
yeah.
I did a good. Yeah, I did explain you well, and you definitely tried to like capture it to the whole. Like you had that intention to keep it forever. So okay.
Hmm.
Yeah. So let's talk about the bubble, or we can say the Venn diagram. It's not properly the Venn diagram. Venn diagram is, you know, Venn diagram looks like something like this. In just order to explain, I'm using this, right?
Yep.
So artificial intelligence is anything that a machine that that takes intelligence to process the output. Intelligence is what? That you are able to process yourself, right? We are
Hmm.
intelligent being. And we have artificial intelligence. That means that we have developed that intelligence. How can we develop that intelligence? Using some form of data or results, right? If someone is looking at the scenarios, they get a bias, right? If I
Hmm.
just show traffic lights always are always red, I always send my friend some videos of my city, right? And always complaining about that. We'll see the light is always red. The see traffic light isn't working. See, so he gets a bias, right? He get a bias regarding that this city has a very poor traffic scenarios or poor traffic functionalities. So that is what a bias, right? And bias is developed using the data, right?
Hmm. Yeah.
So artificial intelligence is an intelligence which we are inducing within a machine or in a model or in an algorithm with the help of some data. And artificial intelligence has a lot of levels where artificial intelligence is a very bigger, like it's a superset. Take it as a
Hmm.
superset in which there is a subset which is machine learning, under which comes neural networks, under which comes deep learning. The LLMs are formed on the principles of deep learning and natural language processing. The task which like you want to perform in day-to-day life has a linear relation, right? It can be, if the data is not too much, you can process it with just an LLM, just in order to get a particular format.
Hmm.
And if not, then you can just use your own machine learning model if you want to look into something very specific.
Yes, that's correct.
Any questions regarding this? So let's talk about AI. We have already talked about it, right? It has ML, DL, NLP, and now LLMs. LLMs are basically subset of. So the difference is clear, right? ML versus DL.
So hold on. I want to make sure that I got it. So we're saying that for
Sorry.
good. So MLs was short. DLs are more dynamic in content. Is that what we're
Yeah.
saying? DLs are more dynamic than just short posts, right?
Yeah.
That's that's the basic, right? That's the basic breakdown, right?
Yeah. Linear
Hmm.
and less data, less data required for this. It captures non-linear, or we can say complex problems, right? And
Hmm.
it is data hungry.
Data hungry.
Yeah, yeah. This is the term used
Okay.
for this. Why deep learning is so-called data hungry, something like that. Considered highly data hungry, unlikely machine learning. I'll tell you why. Because in machine learning, we have a linear relation, right?
Hmm.
We have a linear relation. So in
Yeah.
order to like just capture the linear relation, or just to get that particular line on which all the other data points will fall into places, right?
Yeah.
That particular line will justify the outcome of those data points as well. Getting my point?
Yeah.
Right? So it will simply become like 2x plus 3y is equal to 5. Let's say this is the line, right? 2x minus
Hmm.
3y, or we can say 2x plus
Yeah.
3y is equal to this, right? Now,
Mhm.
how many examples does it need to get to this line?
What do you mean? How many examples does it need to get to this line?
How many data points does it need to get so that the machine learning model can understand, okay, this is the line.
Well, I mean, we just need to know what it one. Just we just need to understand what we're solving for, right? If we're solving for X or solving for Y, right? Then we can have that value.
2x plus 3y is equal to 5, right? This is the line.
Yeah. This is
Okay.
yeah.
So whichever point, let's say x is equal to, um, it's 3 3 minus 1 minus 1.28 comma 3, right? There, there you go. And similarly, x is equal to minus 4 comma 4, right?
Yeah. Do I always have to think about the chart for
No,
every?
no,
Hmm.
no, not for everything. Let's see. Let's take. I'll plot that later. X is equal to minus 2 comma 3.2. Okay,
Hmm.
or we can say something like this. These are the data points, right?
Hmm. Yeah, those are the data points. Yeah.
These are the data points. The machine learning model will understand, okay, what is the relation between all these? There would be some values, right? So, let's say the marks are minus 2, then the grades are 3, something like that, right?
Hmm.
So it will try to capture the linear relationship between the axes, right? There can be more than one axis, like we saw that in the embeddings, right? There were
Hmm.
1536 dimensions. So it tries to capture the linear relationship. Okay. So in this scenario, if there was a line which can cross this line, right?
Hmm.
This axis, or we can say
Yeah.
this axis, then each point would be very close to that deciding line, right?
Yeah. It would
3,
need to be yes.
3y is equal to 5.
There you go.
right?
That's the example. Yeah.
But now, if we calculate the loss, the predicted would be that the line is here, and in this scenario, the actual scenario is bit far from that. So it will calculate the loss. Here the loss would be minimal. Here would be it's bit higher. Here it will be okay. So the average would be around, let's say, 95% accuracy, right?
Mm-hmm.
Let's say the line the data points which are above the line are pass, and the data points which are below the line are fail, right? So in this scenario, then it is 100% accuracy almost, because there is a clear separation, right? But in deep learning, as I already told you, with the help of shown you the example of TensorFlow, where the data was like was very not linearly separable by just a line, right?
Got it.
So in deep learning, the data is plotted in the data present, and the data is in a very complex relationship, and it is like not always linear, but yeah, some relation can be linear, like the age and the blood pressure can be linear, can show a linear relationship, right? Because with age the BP
Mhm.
also increases, right? So
Yeah.
you having a data set that will definitely be having a lot of, or maybe let's say few linear relationship and multiple complex relationship or non-linear relationships, right? Like with
Mhm.
the combination of blood pressure, sugar, and age, it becomes something else. Like it can that be dementia or something like that? It is possible.
Yeah. So yeah, no, I got it.
So it
There's
needs
more things to consider. Yeah.
that is why it cannot decide uh, on just like by seeing just few examples, right?
Hmm. Yeah. So it just tries to give you the best possible. What is this?
Is sorry.
No, no, I just was wondering what we were looking at.
Okay.
Oh God.
Okay. See this. These are the data points, right?
Yes.
And the machine learning model tries to optimize its linear relation in such a way that it is having loss. The loss is minimal, right? For each
Hmm.
and every data point. Now you will ask that the why the line is up for like here, uh, not just in the middle. Like the middle could have been here, right? Here. Why is it upwards? Think of it.
Why is you asking me why is the line upward?
Yeah, the why is the line more like closer to the denser part.
Because that's where the more trendy data is. It's going to be less towards those that aren't aggregated closely. The right answer would be more around where the dots are more dense.
That's right. And the sparsity of this data
Hmm.
is also playing a very vital role, that the number of data points, wherever the number of data points is more, the data will try to follow that pattern. That is also what you said. That's correct.
Hmm.
And this is how it tries to capture the linear relationship in machine learning model, right?
Hmm.
But in terms of deep learning, we cannot plot this scatter plot. We cannot do that. because we are having so much complex relation and we do not know. Deep learning is actually a black box. We never know what is going inside of that.
Got it.
Okay. So basic is clear.
Yes.
Okay. NLP is natural language processing, right?
Mm-hmm.
It's just a library or a particular domain of a subset of AI which deals with natural text, right?
Yep.
It has like before the era of deep learning and the era of LLMs, right? It was
Mm-hmm.
entirely like the industry was entirely using NLP to understand what does that a particular word mean or something a sentence means, right?
Yeah.
Mhm. And there were a lot of techniques which I'll be giving you some views about, like there are token of words, bag of words. Like you had a question regarding that that if a is a word actually just is converted into a number or what? Let's say I take a do example, and it I just say I want a numerical representation of this. So I just assign 21, right? But in terms of embeddings, this would be a 1536 dimension.
Yeah. No, we went over this last time. Yeah.
Yeah.
So
But
I got this one. Yeah. Mm-hmm.
yeah. But where we started from in NLP was that we really assigned door a number 21. There was no embedding. Door contributed 21. Then what, let's say the cat was knocking at the door, right? So the
Mm-hmm.
words the is actually coming twice. So we give it a unique token. So we let's say we give it 2, then
Mm-hmm.
cat we give it 14, was we give it 10,
Mm-hmm.
knocking we give it 15, and the door we again gave it 2, and
Mm-hmm.
sorry, the we give it 2 and the door
Oh.
20, right?
Mm-hmm.
So this becomes the sequence. Now the model understands, okay, 2 is present, 14 is present, 10 is present, 15 is present, 2 and 21 is present. And we say that the output, like the independent variable of this particular thing would be good. Let's say we are doing a binary classification, good or bad, or multi-class classification, good, bad, or neutral, right?
Mm-hmm.
So the machine learning model or deep learning model will just be looking at these, the technology and the like the with the boom of GPUs and the AI processing hardwares, it
Mm-hmm.
has gone too far and more intelligent. But beforehand, we were using just numbers, and we call it a bag of words. Like we collect all the corpus, like if we are having a book, we divide
Mm-hmm.
all the words, right? We just split them, and we just try to drop the duplicates, and we assign a number to each one of the words,
Mm-hmm.
right? But do you see a problem in taking these numbers as inputs and doing multiplication or um like
Yes,
doing
because
mathematical operation?
other if you do multiplication to it,
Mhm.
you could have another sentence that equals the same thing, but not be
Yeah,
the same words. Yeah.
that's one of the very good observation. But another one,
Mm-hmm. Uh, I mean, the packing and the unpacking of that sentence.
okay,
So
that's
the
one thing.
sequence. So by performing whatever calculations there, you can ruin the sequence of that.
Mhm.
So the way that I would probably pass that in is maybe, oh, it's old school thinking, but just like this is the array in style.
Yeah,
Mark
yeah,
2 has whatever, 14 has it next in the array, so I just have
yeah,
numbers
yeah,
in
yeah.
the array, and maybe I'll pass the array is the way that I probably would address this.
Hmm.
Hmm.
Okay. So numbers do have a value, right?
Yeah. Yes.
So let's say the
Hmm.
knocking has the token of
Hmm.
2003. Okay, that is
Okay. Yeah.
possible, right?
Yeah, that's possible. Hmm.
Just copy this. Okay, it has also the very similar meaning, just that the difference of the tense, like it was past tense and it was just is also past tense, right? So it will be, let's say, 2, 14, 10, and it is 21, 20. It is again 2 and 21,
21. Hmm.
right?
Yep.
Both the sentence mean the same almost, right?
Hmm.
And the values it represents, the values it is which are used to represent this into a numerical presentation differ a lot,
Yes, they do.
right?
20 and in
2000.
2003 is
Yeah,
whatever, but
exactly.
the sequence you can see that
Exactly.
there's only one off in that in the sequence of numbers.
Yeah. So machine learning model
Hmm.
and deep learning models cannot handle irregular data, right? They want that the representation of each variable or each column should be like very regularized. In deep learning model, what we usually do is we scale down or normalize the column. We bring it down. Like suppose if something is let's take an example of bank account, bank amount, remaining bank amount, right? Someone is
Okay.
having a 10 million, right? And someone is
Hmm.
having just $5. So deep learning model, when will it will be seeing that data, if we go back here,
Hmm.
right? And if I just plot one thing, what do you think? What would happen?
If you put the 6-2
If
dot
it
over
was
here,
also a data point, then what
hmm
would happen to this line?
then it would tilt more towards the bottom would tilt up some to
Yeah.
kind of
That's very correct. That's very correct.
got it. So how are we going about normalizing
Okay. So this would
the
be the line, right?
values for
Something like
yeah,
that.
go ahead. Hmm.
So that is why we do not give something which is like it should be within a range. Or what we do is just divide it by the largest number. Let's say we have amount, right? Balanced column, and it
Hmm.
has a value of, let's say, and some other account has just,
Hmm.
right? Something like that. This would be the real scenario. How do we make sure that the impact of this is not very large on the machine learning's bias or machine learning's uh, calculations or deep learning calculations? It is just simple. We can just do what we can do is we can divide it by 1025620 divided by just by the same number, right? What will be getting is 1, right? But
Oh, and
in
this makes it all relative now, right? Because you use the highest number there.
yeah,
So we'll cover the
exactly.
complete range. Is that why we do it that
And
way?
and the goal is to capture the relation. That's it. If even if
Hmm.
the relative value is present, we are fine with that,
Hmm.
right? It will become something 0.00000 uh, 1 2 1 2 something. Okay.
Hmm.
Similarly, this will become the same value. So it will be having 1, and it will be between 0 and 1, right?
Hmm.
So that is a much better option than this one, right?
Yes, it is.
And machine learning model will see that, okay, this is 1. So the multiplication would not rise exponentially in case it happens, right?
Correct.
But if we just multiply something with 20 and we multiply it by 22,003, then the
Yeah.
difference would be very, very different, right?
Yeah.
Yeah. So this is why the regularization and normalization techniques were brought into the deep learning and machine learning models, so that we only try to capture the relationship, not uh, and avoid the bias or the value of the columns, right? Okay. So this much is clear.
Yes, it is.
Okay. So let's move to the model one. So foundation of portfolio program management is just the project portfolio versus program versus project, right?
Hmm. Did you ever send, you said you were going to send the,
Yeah, I did make it. I did make it. Let me just open it up. But I just wanted to stick to the program itself because I just added one more thing in the very beginning of that. Where is it? Where is it? Yeah, yeah. So I just added some of the parts which can be helpful for you, and I have divided each and everything where what we'll be doing. So this I will be using this, but I'll mostly go through this only process, and rest of the things I have added some things like own project status reports and build AI powered dashboards, right?
hmm
And personalized AI implementation roadmap for you. And we will be covering the lectures 50% instruction and concepts building, 25% real world case studies, and 25% hands-on exercise with AI tools, right?
Yep.
That makes sense.
Yeah, that's fine.
So that is why I'm just trying to build you like build the mental models and want it to be clear so that we can move forward with ease, right?
Hmm.
So I'm just covering this. What is AI and how it works, different types of AI and generative AI, how AI finds pattern in data to support better decisions, right? That's how what we are doing right now. Real life examples of AI in actions and understanding AI strengths and limitations. Okay, let's cover these two ones and then we'll move to this one, right?
Okay.
So here I have already how AI pattern finds pattern in the data to support better decision. Okay, so I think you are pretty having pretty good knowledge about what we have just gone so far. So
Hmm.
can you tell me that how the AI decides. And AI is just not LLMs, not just the large language models.
How it decides
Yeah.
information?
Yeah.
Oh, okay. It creates relationships with the data,
Mm-hmm.
and based on the relationships created with the data, gives you I like to call it prediction based on uh based on how closely the data relates to each other.
Okay. Or we can say key what the data has is for.
In common, is
Yeah.
that?
Yeah. We what the data has in common, or what are the relationships, or is there any linear relationship or non-linear relationship between the
Okay.
multiple columns? And
Okay.
by
Yes.
combining those, it just finds,
Mhm.
okay, this is the relation and I should follow this relation. AI is not having its own thought process, right?
Got it.
That's
Got
definitely true, right? It follows a guideline. It follows a pattern.
it. So it identifies the pattern, right? And based on the pattern, the relationship identified in the
Yeah.
pattern, that's what it'll
Yeah.
follow to make the decision, right? The prediction.
Yeah. That's why
It,
it's been said that if you just give bad data to the AI models or deep learning models, it will
Mhm.
learn that it doesn't understand, okay, this is ethically wrong or right. It just learns that and tries to mimic the behavior which is present in the data itself.
Mhm.
Yeah. Have you heard of a GPT-2 model?
Yes, but I don't, I mean, outside of just hearing about it, I don't really know too much about what it means, you know? Like, so,
Yeah.
like, since we've been talking, I mean, I've heard of
Mhm.
machine learning, deep learning, and natural language processing, right? NLPs and large language models, but I didn't quite know exactly what they are, right? And when you're
Yeah.
talking, you know, there's just buzz terms, right? Like even neural
Yeah.
networks, that's still like a buzz term. Like it's not real to me, you know?
It will be real to you. I
I hope
don't
so.
don't worry about that. Don't worry about that. Okay. So, I'm just telling you an overview of LLMs right now so that we
Mm,
can go forward and understanding why the input matters more than the output initially, right?
okay. Yeah,
Uh,
I got
if
you.
I just scrape down the data of the whole internet, okay,
Hmm.
will I be seeing some gender bias on the data present on the internet or not?
If you just took all the data, would you be seeing some type of bias with data or?
I'm saying if I just scrape all the data present on
Hmm.
internet, each blog, each YouTube videos data, or each article, news, right?
Hmm.
Will I be seeing gender bias in the data or not?
I don't think that you would be seeing generic bias in the data
No, no,
at all.
gender bias.
Gender bias?
Yes. The
I don't know, man. I don't know. I don't even know what kind of question is that. What I see gender bias. What?
okay. Let's suppose
Male,
we are having
gender, male, female bias in
yes,
data form
yes,
on the
yes.
internet.
Yeah.
Yeah, well, I guess you could see gender bias there, but I don't think that would be the only thing that you see.
Yeah. So the articles or newspaper articles which we see on the internet are having gender bias, right?
Yeah, some will
Thus,
be. Yeah.
even the society itself have a gender bias, not in a lot of countries, but yeah, it does exist in some of the countries. Yeah, do you agree?
Yes.
And same goes with the race bias.
Yeah. Yes. Definitely.
So when the OpenAI tried to scrape all the data and it feeded it into a deep learning LLM architecture, right? And
Mm-hmm.
it trained it. They trained it, and when the output was being generated, what they saw was very surprising, that the output has some gender bias.
They weren't expecting that?
Yeah, they weren't expecting that, but the data which was present into it had some bias. So the model learned the bias.
Okay, so the model learned the bias. Okay,
Yeah,
got it. Hmm.
we show you. Yeah, this one. It is not having that. Let's let's look at this example. A man and his son are in a terrible accident and are rushed to the hospital for critical care. The doctor
Hmm.
looks at the boy and exclaims, "I can't operate on this boy. He's my son. How could this be?" The answer, the doctor is boy's mother. But
Yeah. Okay, got it.
and I saw some examples like there was some chat completion back then, like in 2021, 2020. Then there was some it was booming when they were saying that it can write stories, right?
Yeah, it can. Yep.
You give
Hmm.
it a sentence and it will complete it. So there was a example, like a test being run on GPT-2, and it gave like half a complete sentence, like women's are. Then it gave uh, output as weaker than men. It completed it and it made weaker. The women's are weaker than men. The output was that.
Wow.
Same goes with the gender bias. When the sentence was something like that, the white guy was, then the output were that the white guy was doctor, was a police officer, something like that.
Hmm.
And when we just changed the race, the black guy was, then it just changed the output. It showed that the black guy was a robber or a theft, something like that.
Wow. Okay, gotcha.
So
Hmm.
that totally got derived from what we fed into the system, right?
Hmm.
So we follow a proper pipeline to ensure the data which is going into the system or into the algorithm is not biased,
How
right?
how do you do that? If just the generic, if data in general that we can pull is biased, how do you make the data unbiased?
In terms of machine learning, like the data which you will be handling day to day, right,
Hmm.
would be having numerical values, right?
Yeah, that's correct.
So what is like exception in the like numerical values?
Oh, no, there wouldn't be any exception with numerical values, but you just basically described a scenario where data being pulled in from the internet did show bias,
Mhm.
right?
Yeah. If I just say x is equal to 20, 20 comma 35, right?
That's not male or
Mhm.
female. Yeah, I got you. I see where you're going with it.
Yeah. So this is particularly a bias, or and we call it in terms of machine learning, we call it outlier.
Yeah.
But our majority of the data points do not follow this pattern, right? So if I
Hmm.
just train the model by giving this also as a data point, then my model won't be able to predict the real value, the actual value. The accuracy would drop for all these points. just to make sure that we also take account of this data point, we'll be losing a lot of accuracy. So what do? We just remove it.
We remove it. Yeah, because it's okay. I understand what you're saying.
Yeah. So that's how we do it. In terms of that GPT-2 example, we we build a data set which we manually check if there is data bias or not, right?
Yep, and if there is, it's removed. Okay, got it.
Got it. So that is the thing. If I just ask a chat GPT just to give a random number,
Mm-hmm.
see, it will be giving us, I'll just copy it, 37, right? If I just
Mm-hmm.
do it again, let's see, 37. See, did
Yep.
you get my point?
Yes.
It is why it is always giving 37, because it has a bias regarding towards 37 whenever someone asks this question. So the examples
That's why
which
it
it
always
has,
gives 37.
yeah. If I just do it again, there are chances that it might not come as 37, but there are highly chances. Okay, something like 27, but very much similar, right?
Mhm. I
If I
gotcha.
do it
Okay.
again, if I just run 100 iterations, I would be ending up with 37. See, so
I
this
didn't know that. I
this is
didn't know that
how.
it has its own bias. It's crazy.
Yeah. So with this, I just want to understand. I want you to understand that data, the LLMs, or be it
Hmm.
machine learning, be it deep learning, is
Hmm.
heavily, heavily, heavily dependent on the input data. It doesn't think of its own, right?
Hmm.
So if I just paste this chat in 100 chats, paste this message in 100 chats, I'm sure that I will be getting 90% 37,
Gotcha.
right?
Hmm.
Yeah. Let's go forward. Okay. So we have already seen the bias. We have covered the bias. Bias comes from the data itself, right?
Yep.
Always remove bias to get a generalized, to get a model
Hmm.
which gives generalized results, outputs. Make sense?
Yeah.
Yeah. Let's see the limitations. So, as per this, what do you think that what are the limitations? Like the basic one. Let's take example
What,
of bias of machine learning. Yeah, for limitation
what
of machine learning. Sorry.
we said, what is the limitation of machine learning?
Yeah.
What I'm thinking about, it only supports the linear relationships as a restriction for
Yeah.
machine
That's correct.
learning. So if I have
What,
something a little, yeah, go ahead.
whatever lies outside the forte of the machine learning algorithm is just its limitation, right? If
Mm-hmm.
if we could solve everything with the help of machine learning, then why do we need deep learning in the first place, right?
Mm-hmm.
And same goes with deep learning. Deep learning has a lot of architectures like CNN, LSTM, RNN, GRU. Then comes in LLMs, or we can say LLM transformer architecture.
Transformer architecture.
Yeah. It's a bit complicated, but on that only the all the LLMs are based on. Like I'm just gonna have just show you that what is transformer architecture.
No, it sounds confusing. Wait,
So this is
because you mentioned
the
other terms that you didn't
transformer
give the
architecture.
definition for. Mm-hmm.
This is the transformer architecture. Let me just walk you through. CNN is convolutional neural networks. If we just go with the deep learning, right?
Mm-hmm.
We have CNN, right? We have LSTMs. First, there was RNN, and LSTM, then GRU, then transformer. Okay,
Mm-hmm.
I'll explain each one. Just a quick one-liner. CNN is a model which is used in image processing. So deep learning was required because image data has a lot of non-linearity, right?
Okay.
A dog in different pose and another image of the same dog in different pose, the data is not same. The pixels are not speaking the same value, right? Not
Mm.
depicting the same value, right?
Yep.
The colors would be different, the depth would be different, the brightness would be different, the position of that pixel which is present in the eye of the dog is different, right?
Mm-hmm.
But how does we make a deep learning model understand that these two images are of a dog only? For that particular problem, we have CNN, which is convolutional neural networks. It convolves on the images. It not just by looking at the whole picture at once, it tries to extract the features of the image. Let's say one filter is looking at the is finding the um, what we say ear of the dog, one is looking at the eye of the dog, one is looking at the nose, and one is looking at the tail. Then by getting all these features, it looks at what I have in the output variable, to which it does it match this particular feature. Okay, the output is dog, then it tries to learn, okay, whenever I see these features, I will say it's a dog, right?
Mm-hmm.
But if we give only two examples, let's say a ball and a dog, two separate images, then it is quite clear that the ball doesn't have nose, it doesn't have tail or ears, right? So it makes it easier for the model to understand, okay, these are the features missing in it, it is a dog. But in case of, let's say, if I just give a dog and a cat classifier, then all these features are same. All these features are common in both of them, right? In
Mm-hmm.
that scenarios, the statement that deep learning is data hungry comes in. Why? Because it needs to see a lot of dog images so that it can differentiate between dog and cat. Because in this scenario, the features are same. It has to look at other features, other things by combining the features. Let's say dog has a bigger mouth. Okay, this is one feature. Dog's height is more than a cat's height. That's another feature, right?
Yeah.
Any doubt?
No doubt.
No doubt. That's good. No doubt or all clear.
Okay. Which one do you prefer? Like I got that. I got that. I understand it.
Okay, that's
All
good.
clear. We can say that one.
All clear sometimes mean that I didn't get anything.
No, no. All right, fine. I won't. No, no. I know. I understand this one here.
Okay, cool. So we have CNN for handling with images, and CNN also helps in analyzing the videos. As you already know that the videos are also made up of frames, right?
Yeah.
And we can divide the video into a particular number of frames in which the video was recorded, right? Was it 30 fps or 60 fps or 90 fps, right?
Mm-hmm.
It's frame per
That's
second.
frames per second. Yep.
Yeah.
Mm-hmm.
And we can just analyze each and every individual frame, and we can find out, let's say we have to build a theft alert sort of thing, right? Theft alert monitoring system. Then it
Mm-hmm.
goes through the video. In the CCTV camera is live streaming the video into the model, and the model is just going frame by frame, frame by frame. Whenever it sees a knife and a person with mask, it just alerts, right?
Mm-hmm.
So that's how CNN works. It and going forward with RNNs are actually recurrent neural networks. So it is utilized. It sort of like let's say it analyzes the output, or we can say there are, let's say, there's a train, right? Train has a lot of coaches, right?
Mm-hmm.
And the end coach of the train is, let's say, the input of the RNN architecture. The input is given to the RNN architecture at the last coach. Then the second last coach gets the output from the last coach. It tries to work on the output of the last coach. Similarly, it goes forward, and the output is generated at the engine. So it recurrent, it recursively processes the same data within itself, then gives you the output. Do I make sense?
Yeah. Yes, you do.
Let's show like this. There's one train, then there's one coach, there's another coach, and there are a number of coaches, and we get the output, right? So
Mm-hmm.
the output, it is basically it. This is the representation, but internally it is just revolving, iterating within itself. So it makes sense that the coach is sending the input to the same coach again, and it is processing the whole data.
Yeah, so it just keeps
And
processing this thing, it's like what it
yeah,
gathers from each coach all the way through, right?
yeah. And the internal architecture does look something like this. There would be a input layer, hidden layer, and output layer, right? So it
Mm-hmm.
once it gets the input, it goes to the hidden layer. Hidden layer gives the output to the other layer. Then other hidden layer gives the sends the output to the initial layer. Then it revolves, keeps on revolving, and these neurons tries to predict. Let's say I have trained it the LLM on writing an application, right? But
Mm-hmm.
it cannot just write an application in one go. It will just generate word by word, right?
That's
So
that's
it
right.
will first I have just send it that, okay, just write an application to my manager to take a leave, something to inform, and
Mm-hmm.
it will just generate hello. Then this hello would be uh, generated, and then hello would be sent again to this hidden layer, and along with the input message. So it knows, okay, I have generated hello, and I have to generate this. Then this again goes to the hidden layer. It generates hello manager. Then it goes again, it generates a comma. Then again, then it generates a new line. Again, hi, this is to inform you. Then this circle goes around until and unless the model thinks, okay, this is the output. Or there is a end of sequence token, which we usually add in order to let the model know that, okay, when this is where you have to stop. So the model understands using the input, yeah, we can say that using the training data set, it understands when to stop, right?
Okay. So you have to tell it when okay. And all so I guess we'll get to it eventually on how we'll generate those closeout tokens, right? On when to stop.
Yeah.
Mhm.
If I just say to ChatGPT that generate a story,
Okay.
okay?
Mm-hmm.
Just I want you to just look, not look at the data. I want you to look at how the data is being shown onto the screen, how it is popping up. See,
Hmm.
it is just like it's printing each and every word, right?
Yeah. Yep.
And you know what? That let's say it's looked. So looked is being generated, looked was generated, then the whole output like looked and along with this was sent to was sent forward again. Then what did it do? It it generated the next sentence, the next token, then the same. That was the problem, right? It generates token by token, token by token, token by token. Are you getting my point?
Yes.
So similarly, RNN are also used in time series data because in time series data we already know the past, right? And we want to predict the future or what would happen next. So if I train a neural network based on a huge corpus of previous transactions, previous trades, it can
Hmm.
predict the behavior. Okay, if the silver is going down, okay, I would do this, or the market has done this, right?
Hmm.
So that is the thing. LSTMs are long short-term memory. RNNs had a problem of storing a good memory. Like if I just go to ChatGPT, it has a very good memory, right? But RNNs tend to lose in terms of when we give very huge sentences of huge data, then
Hmm.
long data actually, then it tries to forget because in my sentence, if I just look over it again at my
Hmm.
input, right?
Hmm.
If I just remove on chemical and this, would that make any change?
If you did what? I'm sorry, can you repeat that? If you just did what?
Okay. If I just remove this on, right? Will that change the output a lot?
No.
If I just do this, if I just do this, will it change? It will
Will
still
it change
remain the
the
same,
output a
right?
lot? No, it's the same. It'll give you the same. I don't think that that
It
changes
means the
too.
same thing. But ChatGPT is able to handle that. But RNNs, when it couldn't understand what is the main thing which I need to work on. So in that thing, a lot of data which was sent to the RNNs was making it like unstable with the increase in the length of the input, right? That's why
Hmm.
we got LSTMs. LSTMs are long short-term memory, right? Long short-term memory. What it does is it has a sort of gate in which it tries to feed in what are the key things which I need to uh, keep for the long term, and what are the things which I just need for the short term, right?
Hmm.
So it was an advancement of RNNs. If I just try to go and explain each, it will take just a day to explain each. Just understand that LLMs like RNNs and LSTM and GRUs are predecessor of transformer, which
Mhm.
were having some problem either with length, handling length, either with managing what was the core idea of the input, what was the core uh, intent of the input, or like the length. There was a limitation in length in processing, how much it can process, or attention mechanism, like where to give my attention. Hey, you there?
Yeah, can you the Transformer one? Can we cover that again? I just want to make
Which one?
sure. Huh?
Which one?
Transformer.
Okay, transformer. So transformer architecture is basically this one, right?
Mm-hmm.
Don't get stressed about it. It's very simple, very simple. Understand it in such a way that I'll be explaining it. We will divide it into the encoder part. This is the encoder part, and this is the decoder part, right?
Okay.
The encoder part is something which we have already discussed, but
Mhm.
not in terms of this presentation. We have discussed the embeddings, right?
Yes.
So embeddings are what? A numerical representation of words, which also
Of
capture
words.
the,
Yep.
yeah, which also capture the semantic relationship, right?
Okay. Yes.
And whatever I give the input, let's say I gave this input, right? Generate a
Mhm.
story, 1,000 words, PFAS, right? It gets converted into a numerical representation, right? It
Mm-hmm.
gets converted into a numerical
Yeah.
representation
Mm-hmm.
where it understands where each and every word is present in the sentence. Just give me a second. I am getting a call. Yeah, sorry. Actually, my friend forgot his laptop on, at his home and he's in office. No worries. Okay.
Mm-hmm.
So the input, as we have just have a look here, gets converted into a numerical representation of words.
Mm-hmm.
And how does it actually make sense to the chat GPT? How does it actually understand, okay, what is written? Why I just need to uh, focus on PFAS, right? How
Mm-hmm.
does it understand? Why not just focuses on generate a story which can be on any topic? Why it is generating on particularly this topic? Even without mentioning it explicitly that this is the topic, right?
Yeah.
So there
So,
come, yeah,
mhm, go ahead. No, no, no.
no, no,
Finish. I'm listening. No, no. Go.
okay. I have a vector embedding on which each token represents the words and its semantic meaning. Then it calculates the multi-head attention. The numerical representation goes into the multi-head attention. Then it tries to capture the relation between each word. What does generate mean in this sentence, and what is the relationship between generate and each word in it? Okay, so generate has a very high similarity or relationship with story, and generate with thousand and words, and with this story has a relation with PFAS, words, and generate, something like that. If I just say
Okay.
explain me how multi-head attention would work on this sentence. The model does not see words, as we already discussed, right? It will get tokenized each and every word, right?
Mm-hmm.
For 768. That's a basic one. We have talked about 1536, and it has a 4096 dimension for the other model. So it gets converted into query key value matrix, and each 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 word asks, what am I supposed to do, right? And the
Mm-hmm.
answer for this is this particular word answers to this generate word using multi-head attention. It is internally processed. We do not know what is happening in the in inside for each word. That's why sometimes ChatGPT tends to give another answer which you it was not supposed to, or you it wasn't asked, right?
Mm-hmm.
Sometimes it happens. We are asking something and we get something else. So generate word, ask, what am I supposed to do? The story says, okay, you are generating a narrative text, a length constraint, this is, and the core topic is this. Attention lets the sentence know, each word know that what is their specific contribution or the target in the particular sentence, right?
Mm-hmm.
We can say head one, it generate and story. The head answers the user wants to create wants creative text generation, not fact or codes, something like that. And then again, 1000 and words, what is the relation? Target length is equal to 1000 word long format output. And
Mm-hmm.
again, PFAS ask, and the story must revolve around PAFS, not drift away. Then again, story context token in it predicts next, narrative tone, characters, and this. So it is just, if I just say what is LLM, if I just say what is LLM, then what would you say?
If you,
LLM or
if
transformer?
uh, eh, I would say that it is an architecture
Mm-hmm.
that uh, assigns. It's an architecture that encodes input and tokenizes it to provide relative responses. That's probably how I would
Okay.
attempt to tackle it.
Okay. As we when we saw RNNs, right?
Mm-hmm.
RNNs. It was generating one token at a time, right? It first generated hello, then again the input went into it, then it generated manager, then again this is Shikhar or the trainer or something. It goes by token. As we also saw the output generation, it was printing token by token, word by word, right?
Yes, that's correct.
So can't we say that LLMs or the models and the LLMs or transformer architectures models are just next token predictor? Can we say that? Will that make
It's a
sense?
token predictor. Yeah, I see it.
Right? It's
Mm-hmm.
having, it's not having its own understanding, right? It's not having its own thought process, right? It's not having its own knowledge. It's just being fed into the system. Then it just predicts the next token based on what I have just said and what it has been generated, right?
Mm-hmm. Got it.
If I just stop, like, if I just say, okay, explain me how this, okay, I will just say, complete the sentence. The white guy was a, see, now they have trained it, right? I
Mm-hmm.
can't complete that as is, because there were special instructions given to the model, or being the data was provided just to avoid the gender bias, and these were the things which were set as the output, so that it is acknowledging it that it is not good, which is totally fine. It's not good, right? So now it
Mm-hmm.
is doing its job. But the thing is, it is printing this thing, this part of the sentence which we have given. The white guy was a, it is the same, right?
Mm-hmm.
And it has just generated one token, two, three, four tokens, right? So
Yeah.
it got input, it gave it it gave it to this layer, it generated it, generated another input, input for the hidden layer, previous hidden layer, and that token again went forward. It generated one output, then again it went in the initial layer, then this loop goes on.
So it's just looping, right?
Yeah, that's it. You see that NX over here?
Yeah.
That NX is just n times this
The
particular
number that it
part.
loops, right?
Yeah,
Okay.
each and every model like ChatGPT, Claude, Grok, they have their own architecture, but the core principle is this only. They can have 27 layers, they can have 50 layers, right? To
Mm-hmm.
make it more and more better, to capture more complexity. If in deep learning architecture, if we want to capture more complexity, then we will eventually just increase the number of hidden layers, increase the number of neurons, right?
Mm-hmm. Yeah.
Similarly, these are having feed forward, whatever, feed forward is just a neural network. Feed forward is just neural network. Feed forward neural network is foundational artificial neural network where information moves in one direction, in only one direction. So it is just because it is a next token predictor, right? It is a next
Yeah.
token predictor. So the out it will only try to generate the output because the training it has already done. The training part is already done. Now what? It is not training itself on the go, right? If I just download the chat GPT model on my computer and I am having a good hardware, then I can get the same efficiency. The same output would be given by that model as well because it is not having any getting any training on the go. The outputs which it has generated so far will not
Mm-hmm.
be are not being used as training on the go. It might be the charts might be used later on, let's say in the next versions. It might get used, but not right now. It is a trained model, just like a deep learning model or machine learning model, which is trained for predicting whether it's gonna rain or not. It is same. Did I confuse you?
So so is it closed? Is that neural network closed? Or the number of
Neural,
iterations that it goes through?
yeah, yeah. Number of iteration through which it goes through are fixed, right?
Okay. Thank you. Yeah, that was the part that.
Fixed. It is fixed for one instance. It won't be variable. Like if I define a model that you have to iterate 50 times, then it will iterate 50 times, not more than that, not less than that. And for each and every task it gets, it will do the same. Got it?
Yeah. Can you go back to the layer diagram again, where it has the hidden layer?
Yeah. Let me show you a
Okay.
FNM. Take this as an example. There are, and let's say this is the input of the column temperature. This is humidity. It is wind speed, and this is let's say cloudiness, right?
Mm-hmm.
Each neuron attends to it. Each neuron sends the output to the other neurons, right, in the hidden layer. These two neurons see the output, generate the output, and there is one output which is in the target column, right, which we have already given in the supervised learning. As we we have already gone through about from that like this one. The grade is the target column, right?
Mm-hmm.
So the grade is the target column. Whenever this particular output makes a mistake, understand this very well. Ta- uh, I would then explain it with the help of human brain, right?
Mm-hmm.
Let's talk about that first, and that would make it easier. Suppose you are calculating, you have been asked to solve a problem, right? And you have calculated it. You follow step by step that what should be the next step. I got these, and what does it make sense, and where should I go ahead with, right?
Mm-hmm.
What is the process? This is the same process. Do you follow, no?
Yeah, think about it, think about it. To go through
Yeah.
all of the steps until I produce the output, yeah?
Then what happens? If the output is wrong, then what do you do? We reiterate it,
Re
right?
yeah, yes.
We only fix the mistake. Where what was the mistake? Because that is, if the whole answer or the whole solution was wrong, that is, then the whole solution needs to be scraped out. But if we have just made a small mistake in some numeric in calculating something or doing some multiplication, then we just need to correct that, right,
Mm-hmm.
in order to match the output. So I, that's actually a rabbit hole. Let's take an example of this one. Yeah. So each neural network, or we can say each neuron are the most basic entity in a neural network layer, right?
Mm-hmm.
And each neuron has its own weight and its own bias.
Mm-hmm.
Are you, if I just give you two options, right? Two food items, and suppose you like pie, and I give you option of cake and pie, right? You have a bias for the pie, and you will
Yes, that's mm-hmm.
most certainly end up choosing the pie.
Fine, yeah.
Yeah, so that's the thing. Bias and weight. Weight actually helps the neural network, like each and every new, even if we are calculating, let's say we are calculating in the head, it travels through a lot of neurons. Not just one neuron would be calculating, doing all the multiplications, right? A
Mm-hmm.
cluster of neurons would be utilized in order to calculate a particular problem, right?
Mm-hmm.
Similarly, when we have a nested neural network, there are multiple neural networks, each having its own weights, right? This
Mm-hmm.
neural network is connected with this, and this, and this. And it is having a different relationship between with each. It is having a 0.01, 0.02 with this one, and 0.03 with this one, 0.03 with this one. And it is having
Mm-hmm.
a bias of 1, 5, and okay, these are the input layers. So these are the inputs, right?
Mm-hmm.
And it is having a bias. This layer is having a bias of 0.8337, 0.8764, and zero point 0.90 and zero point 0.93, right? These are the biases of it. And the weights. Now, the weights and bias are actually the way of calculating it. If I just say 0.837 in plus 0.18 into 0.19 plus
Mm-hmm.
into 0.86. It will eventually, if I just zigzag, if let's say there were 20 neural layers here, right? 20 layers here. And
Mm-hmm.
if I zigzag with it, right? If I just follow a random path, or I just say, show you uh, deep learning, right? These are what? Neurons. These are neurons. I'll add more hidden layers so that you understand. I'll increase the ratio and noise as well, right?
Mm-hmm.
And output is just 2, right? So we'll be just keeping it 2. And if we just run it, right?
Mm-hmm.
It is just still trying to minimize. The loss function has already dropped a bit. So we'll just now, if I just look here, the weight is minus 1.3, 2.1, or here it is 0.3, here it is minus 1.2. So these are the weights. And if I just follow this, like this is the strongest relationship, right? The weight. If I just follow this path, and there, and there, and there, as you can see, it is traversing through a lot of neural networks in order to capture that, right?
Mm-hmm.
I think you're having some
No,
doubt.
I'm here. I'm following, and
Okay.
so I'm making it make sense to me, right?
Yeah.
So the weights are, so I just want to call this back. The weights are the actual values, right? And
Yeah.
each
Weights
neuron
are the
in there are what?
weights are the actual values which help
Oh, the
and
actual values. Yep, yep. And then the bias is whatever the neuron chooses, right? Like
bias
its
is just
favorite
like,
based on the input that it has, right?
yeah, bias actually defines how does the particular neuron behaves, right?
Mm-hmm.
Bias is bias determines the behavior, and weight the value it holds. So if you just take an example of that, we are having 8 billion 8 billion neurons, or
Mm-hmm.
if we talk, we say 8 billion connections. Each line is having is called a connection, right? A
Mm-hmm.
parameter. So each weight
Yep.
and bias is just like a huge number of numbers, a huge number of matrix,
Mm-hmm.
a very dense matrix, and the input comes in, and it traverses through one of the path and gives you the output. If I just
Okay.
say a high, and I ask the model is trained for completing the sentence, then the high input would come, right? And
Mm-hmm.
the again would be the next token might be start. It will start. It will
Mm-hmm.
traverse this path, this path,
Mm-hmm.
and this path, and it will give. And यहाँ पे will be having a lot of neurons. Let's say this is hi my, this is
Mm-hmm.
name is
Mm-hmm.
something X.
All right, cool. I got this part then. I got
So
it.
if
I
I
got
just
it
give you,
down. I
mm,
just wanted to make sure I can associate the proper words and terms together, right? So I
so
think I did
it
that right.
traverse from here, and when the input is just high, the output would be given through here, because the model has a bias for high, and it follows this particular path, and the weights make it because what is the end goal? The end goal of each and every machine learning, deep learning, or LLM architecture is algorithm is to minimize the loss. This is the loss, right? Minimize the
Mm-hmm.
loss between the actual value and the predicted value. That's how we calculate accuracy in terms of machine learning models, right? Any questions?
No, thank you. That's a lot to get into, but I understand it.
No worries. Just let me know. I'll help you there.
No, 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 no. I got it. I got it. I got it. I got the some good definitions for bias, weight, the connectors, and the goal, and that's what I wanted, like, to help through here. So I
That's
got
good.
it. Hmm.
That's good. So the weights helps in calculating the loss function, and bias decides where through which neuron or through which neural next neuron would be causing least loss,
Hmm.
right? And they have got each values by training. They have got these values of weights by training. Why these aren't the same? Because they have got trained upon it, right?
Hmm.
And if I just say, as I told you that about generalization, right? Normalization of data.
Hmm.
You remember this one? Uh, where is it?
It was the
This
sentences,
one.
yeah,
This one.
the bank accounts, right? Yeah, I got that. Yeah. Hmm.
Do you see anything similar here? The weight value is 0.48, right?
Hmm.
Minus 0.5, 0.26, minus 0.34, minus 0.26. The values are not very large, right? They vary between 0 and 1,
Hmm.
so that the
I got
model can understand the relation. Not There should not be a like irregular data, so that, or else what would happen if the weight is here, the this weight is, suppose, let's say 20, then the most of the inputs would traverse through this, right?
it. Hmm.
It is having the most knowledge, something sort of that, which is not possible. And it will like just uh, bombard the training process. Why I would say that, if I just increase the learning rate, let's say 1, right? If I make it 1, then this architecture would be learning from each data point. Let's say this data point would have an adverse effect on the training parameters, which are weights and biases. The weights and biases would drastically adapt themselves in order to minimize the loss function for this. Let's see the training data, training losses. It is very
Hmm.
edgy, sharp spikes. Whenever it sees a data which is not, whenever it sees an outlier, the spikes kick in, right?
Yep.
If I just reduce the neurons in the output layer, then I run it. See, did you get it?
Yep.
We just take another example. Let's take in this would definitely make sense. See, each data point, when data point gets in, then there is a very drastic effect on each weight. See, the weights went to minus 12, and we are having a very bad test loss, right? So all the relations are very heavy. We want to normalize it so that it can generalize well. We will just reduce the learning rate, reset it, and run it. Yeah. As you can see, it is drastically going like smoothly going down. Then on the time of convergence, it will try to minimize the loss. It's still having the problem, but still I think it will work. Maybe more time is required. Epoches are basically how many times the data would be traversed through in order to get to the minimum loss. Any questions for so far now?
No, no questions.
Are you confused?
No, I'm not confused. I got this. I understand exactly what it is that you're saying, how you're training the data here. But
That's good.
this doesn't, this is not so fun right now, this part. It's not so fun to watch. So I wanted to have some fun, but
You
this
want
part,
some fun. Okay. I just
yeah,
wanted you
not
to
so fun.
understand the core behind so that just by looking at the problem, you're able to understand, okay, this is what needs to be done here.
Gotcha. Understood.
Yeah. So this is not like the only part, but it is the basic part which needs to be there.
Hmm.
Yeah. Can you just give me a moment? I just need to
Sure.
take a water break.
No, no problem.
Yeah.
Hello?
Yeah. There?
Yeah, I'm here.
Okay. Okay. I think it is time to just move to the fun part, right? As I already told you that you have to stop me, right?
Yeah, no, no, man. You go real deep, and I was in there too. I was like, okay, fine, because I was trying to understand the relationships a little better, right? But after
All
after you
these things.
explain the relationships well, right, with
Yeah.
the weight and bias, right, and those connectors that they're just parameters between the neurons themselves, right, and that
Hmm.
the main goal was just primarily just to see if it can minimize any loss between the actual value and the predicted value. Like to
Yeah.
keep that, it was cool, but adding the additional neurons to the thing, I was like, oh God, oh God.
No,
I can do
see, if let's say
it. Hmm.
there's a baby, right?
Yeah.
He is a newborn, or
Hmm.
and there's a old man,
Hmm.
right?
Yeah.
And we give a problem to both of them. The problem is same, right?
Hmm. Yes.
The baby might not understand what is the problem,
True. Got it.
right?
Hmm.
Because his neural network connections are not fully developed yet. He has not seen those patterns yet. He has not
Okay.
seen those patterns, and he has not made a mistake. If he has not made a mistake, that means the loss was never calculated, and he couldn't adjust the weights and biases of his own so that it can generalize well. It can add more neurons into the layers to understand the complexity, right? Whereas the old man, he has wisdom, he has a lot of experience, he has seen a lot of patterns, and with that, it has also its mind has also just increased the number of neurons, right? And
Yes.
a lot of connections. So
Yeah, that
larger
makes
number
sense.
of neurons means the complexity. If the complexity is high, then we increase the number of neurons, right? Just
Hmm.
this is the just the difference. If the complexity is high, we increase the neurons. So that the see, let's take this this layer, any neuron, whichever is present, right, is X. This is X, this is X, this is X, right? This is also X. This is also X. This is also X. What is a nonlinear relationship? It is a high degree polynomial, right?
That's
Let's
correct.
say 4x cube plus 6x square minus 18x is equal to 0. This is a high degree polynomial because x to the power cube, x to the power 3, right?
Hmm. It's more
So
than two-dimensional. Yeah, I got you. Hmm. Yep.
if I add just 6 layer, so each neuron, it traverses through x into x into x into x into x. So it becomes 4 x to the power 4. 1, 2, 3, 4, and 5. X to the power 5. So it becomes high degree polynomial. If we add more layers, it can capture more curvy natures, more intense or complex relationship between the data, right? That is why we need it. If the complexity is more, then we increase the number of neurons in each layer. If the complexity is less, then we decrease the number of neurons in each layer. There are two ways in for adding neurons, is by introducing neurons in the layer itself, right?
Mm-hmm.
Or adding or removing layers. So there's nothing to worry about neurons. You can, and the best part of it is that you don't have actually a method to calculate how many neurons you should use.
You
There is
just
no
put
definite goal,
as many
because
as you feel, as many as you feel needed.
yeah, your issue is
Okay.
justified.
Yeah, yeah, yeah. No, no, I got you. I
Yeah.
got you. Yeah, yeah. Mm-hmm.
Because in an instance you won't be able to understand how many neurons are actually required, and you won't be having any idea of the data itself, because it is very complex to understand how many neurons it would require.
Yeah,
So
that's true.
either way you are not going ahead, so you have to just play around with it. You just do it, then you run it, calculate the loss, you make changes in the neural network, you again train it, then
Mm-hmm.
see if the training loss is decreasing or increasing. If it is increasing, then you just go back to the previous one, add a
Mm-hmm.
different use a different approach. That's why we add regularizations techniques, so that the loss
What
can.
So can we go through exercise and maybe we're going through a problem where we're in the playground, like, oh, to make sure that the, kind of training.
Mhm.
But so do you have
Yeah,
a problem or example that we can use to actually see it work and
yeah,
prompt
sure.
it with our problem? Yeah.
Sure. We can go through, we can create a problem, right?
Mm-hmm.
We'll just go to collab.
Mm-hmm. And you never shared the worksheet with me from the notes from last time that you had in collab.
I'll share it today. Sorry
Okay,
for that.
thank Yeah, I wanted to walk through an exercise here that
Yeah,
I have.
we'll be creating a basic neural network for binary classification. As we can see, we are having 0 and 1 in this. If I just see at the end of the data, you can see it is having 1, right? So it has
Hmm.
0 and 1, 1 for true and 0 for false, right?
Yep.
We have this TensorFlow, import TensorFlow, or we can just run it as it already has TensorFlow. I think my notebook already has TensorFlow in it, so it will just run it. Okay, we have run it. Yeah. So we got total parameters as 225. What are these 225? If I just go back here, 1, 2, 3, all the neural network connections are parameters. These are trainable parameters, right? Each connection has a weight. Each connection between the two neural network has a weight. So these are trainable. The weight can increase or decrease in order to optimize the output. It will adapt itself. So we have chosen 16 neurons in the first layer, then the second layer it is 8, and in the output it is 1 neuron. So if I just take this 1, 2, 3, 4, 5, 6, let's say it is 6, and we have 8 layers, 8 layers, and we reduce the hidden number of hidden layers, and we just, yeah. So this is what it will look like if we just represent it,
Hmm.
right? So number of these and these makes total of 225 total parameters, out of which all the parameters are trainable. Any doubt? Hello?
Yeah, I'm here. Yeah. No, I see it. So what are non-trainable parameters? I see we have zero
Non-trainable
there, but
parameter. Okay. Suppose if I just freeze that some of the layers, some of the neural network, I just freeze this layer, or I just freeze few of the neurons in this layer, right? Freezing in the
hmm
sense means that the trainable parameters would not change. So it becomes non-trainable. If I want that this particular neuron is already, this particular connection is already performing good, or I want to just train that we do not want all the parameters to be trained, because it definitely reduces the training time, as well as the other neurons can get better information. In that scenario, what I will do is I'll just freeze some of the weight, some of the neurons. I'll
hmm
show you. I'll just show you. Freeze some of the neurons. Got it? If I just
Yep.
do this, see, now the trainable parameters are 225. Trainable parameters are 145, and non-trainable parameters are 80. If we add all these two, then it becomes 225. And how did we do it? We just model dot layer 0, right? Dot trainable is equal to false. Layer 0 is this one, right?
hmm
Layer 2, layer 3. So we have just trainable, set the trainable equal to false. We have freeze the first layer. So it becomes that these neurons, the connections won't be trained. Only these one would be trained, because we have two layers, right? So these one would be trained. We have 8 here, something 8 or what? Yeah, 8, 16, 8. So we have 145 parameters, which are these ones, which will be trained. And in this row, there are 16, which will not be trained. Got it?
hmm
Let's see. Let's move forward. Model compiled successfully, that this architecture got logged into place, and we have a model, and we give it xtrain, ytrain data. Xtrain data is what? We'll go xtrain, xtext, ytrain, and ytest. And we have a library train test split. We split the data into a training data set and a test data set. How will
hmm
you perform? How will you analyze whether the model which got trained is actually working or not? You have a data set, you will divide it into, you will take 80% of the data for the training, right? And
hmm
you, once the model has got trained, you will test it. test the model on the 20% data which you have kept for testing the model's outcome or performance. Let's go over here. Ratio of the training to test data, right? 90%. So this is the training data. If I just reduce, see the number of inputs getting decreased, right?
Mhm.
See here, the data is less here. Does that make sense?
One more time, I think I'm lost.
Okay.
One more time, I think I'm lost.
Okay.
And
Okay.
I know
Okay. No
we're
worries.
we're coming up on time too, so but I think I'm a bit lost here.
Okay. I'll explain it in this manner. Let's suppose we are having this.
Mm-hmm.
Okay. Let's
Mm-hmm.
suppose these are the random numbers. Or
Yep.
what we can do is we can just go over here, over here, and just we'll just copy it, copy this one, right? We'll just paste it. I'll just paste it here, right?
Mm-hmm.
Let's say and this is the whole data. Here
Yep.
is just 10 rows, 10, 20 rows, but in the real life scenario, it would be millions of rows, right?
Yeah. Yep.
I just took this amount of data.
80%. Okay. 80% of that data. Okay.
I got it here and I use it for training the model. This data will be used
Oh,
for
okay.
the
All right.
by the
Well,
model
I'm caught
just to.
up. I'm caught up. You don't have to repeat it. You don't have to repeat yourself now. I got it. Cool.
That's good. Okay. And when the model got trained, right, we will be
Yeah.
testing it on the remaining data, so that whatever the
Mhm.
relationships the model has captured, whatever it has learned after seeing 80% of the data, we'll test the model's performance on this amount of data, which is also coming from the same data set, so that we can evaluate the model's performance, whether it is giving accurate results or not.
Mhm.
Got it?
Yep.
That's good. So similarly here, if we reduce the ratio of training to test data set to 20%, we can see that data has reduced, right? If we
Yep.
increase it, so we are taking a larger portion of the data set, right? So in the training, a large amount of data set is used. Let's go back. So it basically X train, Y train. What is Y train here and Y test is here? Y is the X is the input columns. X train, X is the input column. Uh, let's see. The output is pass, right? It is a binary classification. The output is pass, true or false, 0 or 1, right?
Mhm.
So it is the
Yep.
output. So we say this is Y. This is Y. And the rest of the fields, these fields are X. Okay. So this is
Mhm.
these are the independent variable and this is the dependent variable. These are the values of X and this is the value of Y, which we want to predict. So we give X and find the value of Y. So model takes value of X and then it adjusts its weight. It calculates the output based on this. On the first try, what it does is it gets these weights: 1.5, 60, 5, and 0, right?
Mhm.
And it tries to predict the output. It is 0. The actual output is 0. That means X y y train y train is 0. X train is what? This part.
Mhm.
This part is X
All
train.
of that.
This
Yep.
goes as input, and Y is what? Our
Zero.
Y train. Similarly, for the test data set. Similarly, for the test data set, This becomes our X text,
Mm-hmm.
and this becomes Y test.
Okay. Yep, my test is one. Okay.
Make sense?
Mm-hmm.
Then our training shape becomes 9 by 4. X Y train becomes 9 because there is no other column, just one column is used, right? So that means from 0, this one 0, from this 0 to this 0, let's say, is are the 9 values which are present in the Y train. And for the X, it is 9 comma 4. That means, sorry, from this row till here and till here, all these values are misused except for the last column. Got it?
Yes.
And similarly, it is 3 by 3 comma 4 and 3. Take it as a matrix, right?
Yeah.
Yeah. Then we go forward. We have chosen the designed the architecture of the model. How many layers would there be? It just you can just have, I will just explain it. Activation functions. You can also have a look by your own. If you're having any problem, I'll explain that. Right? These are activation functions just so that the training can be smooth. Right? As we saw when we were having a very a lot of layers, and the learning rate was very high, let's say 3, and we increase the noise, the training is not stable, right?
No, not at all.
So that is why we are having ReLU. The rate is ReLU, right? We are having the same thing, ReLU over here.
Mm-hmm.
It makes the it initializes the weight in such a manner that the training is stable, because initially all the connections are zero. All the connections are zero. The weight of all the connections are zero initially, but they need to have some value in the later on process, right?
Yes, they do.
So then it will understand the relationship between the data, and it will try to uh, it then only it can predict the output. So that is why we have ReLU over here, so that it can initialize some weights, not zero, not very large value, so that the training may get unstable. Then we move forward. History is equal to model.fit. Then we fit the model. We provide just the training data set of the X variables, that the independent variables, and we give the dependent variable, so that it first sends the input from this end. X train goes from this end, X goes, and Y is waiting at this end, right?
Yep.
Then again, what happens? The training loss is calculated. At this end, training loss is calculated. Then the weights starts to get updated in backward propagation. In backward flow, it gets back propagated. And the weights, each connection gets updated, whichever is causing the problem, right?
That's correct.
So when I want to recall you, uh, when we see feed forward, right? Feed
Yep.
forward is what? When we are going in this direction from left to right, and we are just going towards the output. It is called feed forward neural network. And when we are actually in the training process and we want to reduce the training loss, when we go backward, it is called backward propagation. So in this left to right, it is forward propagation or feed forward neural network, or in the backward, we call it back propagation. Feed for
Back propagation is from right to left, right?
Yes, back propagation is a process in which the algorithm is designed to update the weights of the neural networks layers in order to minimize the loss function, right? And it is pure maths. How does the weight gets updated? It is I guess weight old minus weight into del L by del new. So Del L is learning rate, by del new is the shift. So I'll, if you want to go into the maths, I'll definitely let you
No,
know.
no, 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 man. No.
Okay, okay. So what we'll do is we'll just train it. Let's see. So for the first iteration, test loss was 12.3413 and test accuracy was 0.333. So it is 33% accuracy on the test data set. Sample prediction were these. Sample predicted class were these. 0, so it has predicted 0, 0, 0. But the problem is that we have 1, 1, 1 over here. So it is not giving the optimal results, right? So what we'll do is we'll just undo it, or what we can do is we can undo and copy it, and we'll redo it so that we update the model. We'll say model 1, we'll make it model 1. We need not to import again and again. Once we have imported, it will be persistent throughout the collab, right? I'll just
Hmm. It
hit
will
it.
be persistent throughout
Now
the until we upload a new one, right?
throughout the environment, it will be.
Okay.
We'll print, sorry, we'll print the model 1 summary. And as you can see, we are having 225 parameters again. And in this, we were having only 145 parameter and trainable parameters. So we'll just replace it with model 1 dot compile. So the model 1 has compiled. We'll just fit model 1 dot fit. It is training. Modern training completed. And we'll now just predict what is the output. See, test loss has reduced from 12 to 51, right?
Hmm. That's
And
nice.
test accuracy
Hmm.
0.66. So now it is much more accurate. Okay. Now, if we just tweak in bit, tweak in a bit, let's say we increase the number of dense layer, just one. Okay. We have added one more layer, right?
Hmm.
And we will just keep the neural networks in this layer as 10, let's say, right? Look, keep on looking at the trainable parameters.
Hmm.
Currently it is 225. Now,
Yep.
if I just run it, it became
The result at 47.
347. Yeah. If I just make it more dense, let's say I make it 100, it will just go to 259, 2597,
Yeah.
sorry, right?
Hmm.
Similarly, I'll just make it this much and I'll go ahead. So this is the loss, binary cross entropy. Let me explain that as well. Okay.
Hmm.
So binary cross entropy or log loss measures the performance of a binary classification model by calculating the penalty for probability deviations from true labels 0 to 1. What is the deviation from 0 to 1? The output was required to be 0 or 1, right? And how much did it deviate from that? Did it give 5? Did it give it -3? Then this loss function is calculated. And the aim of the deep learning architecture is to minimize this loss by updating these weights, right? By updating these weights, the target of the deep learning architecture is to minimize the loss. If I just go in the, we do not have that loss calculation. No, we do not have. Okay, we do not have the. So this is a one type of cross entropy, one type of loss calculation, because we are using binary classification, we are using binary cross entropy. There are a lot of other loss functions as well, mean square, MSE, mean square error, right? So you'll get to know about these on the go. We'll compile it again just in case. See, test loss had decreased, right?
Mm-hmm.
And training accuracy has increased from 0.333 to 0.667. We'll do it again one more time. We'll just add more layer because we do not know how many layers do we need. Now the parameters are 419. We'll do it again and again. See, notice the time. When we were using less parameters, when we was using less neurons, then we were have the time for training was lower, right?
Mm-hmm.
And as we keep on increasing the time, increasing the neurons, let's say I just make it 80, just a small difference, right? Look at the parameters, trainable parameters. It
Mm.
got up to 1787. Now I'll just notice the time to train it. It previously took 7 seconds. Now let's look at the time. Okay, it took less. No worries. Let me make it 800 or make it 100. Then let's see. 10,517. And let's look at this. So the time in this scenario increases sequentially, but the models are like the hardware is good enough to handle such a small data set. If we had let's say 10,000 rows, then it will just take around 15-20 minutes, right? And let's see the accuracy. Now let's see, accuracy has test loss has decreased from 4.9 to 4.106, right? So this is how it works. It starts to predict. And if I say add a prediction case using model 1, pass the input based on the data. Okay, got it.
Yep.
So what it does is new staging. Now the model has already been trained, right? On a data set. What was the data set? This was the data set, right? The model got trained on this data set, and now model understands what are the parameters, what are the things like hours studied, attendance, sleep hours, practice test. Was he pass or fail, right?
Mm-hmm.
Model understood this. Now, when we are utilizing the same model to predict a new data, suppose a new data came in and it
Mm-hmm.
provided its x values, right? X
Yep.
train. We columns are x train dot columns, right?
Mm-hmm.
And we are using prediction probability model 1 dot predict. We are passing the data to this model, and how the model behavior has been trained is that it gets x train and it predicts y train, and it tries to minimize the loss, right? And predicted class, if greater than 0.5, it is int and it will be printed as 0 or 1. So the output is 1. So does that make sense? Because 3.5, 72 attendance, 6.5. It has already taken two practice tests. Will he pass or fail? Let's look at the data. What does it say? So if I just say practice test is the second last column, so this is the second last column. So whoever took 2, 2 and 2, right? And whoever took like 72 classes, 6.5 hours of sleep and 3.5 hours of study, right? Was about to pass, something like that. So anything more than that would result in pass. If we have more data, we can definitely make it more and more accurate. But you get the intuition, right?
Yeah. So my question to you is, how do what was the range by which we determined
That wasn't
that everything
very,
was fully trained, that our
sorry.
network was fully trained? Like when we train our network, right? We were running through iterations of the data, right?
Mm-hmm.
At what point did we say like, hey, it is fully trained when the precision was what rating?
When we see it is
Less
having
than
test
one?
loss, we entirely depend on test loss and accuracy.
Okay.
If we start to see a very good test loss, it is greater less than 0 and 0 point. If it is
Mm-hmm.
0.1, it is
Mm-hmm.
considered good, right? And the test accuracy is above 80-85%, it is good. It should not be more than 95%. The test accuracy should not be more than 95% because that indicates that your model has overfitted on the training data. It got overfitted. Like it has captured all the noise, all the patterns, everything, which is not good because in the real life scenario, you never know what data is going to come in, right? So the model, it's just like the overfitting is just like the line is justifying the point over here.
Oh, gotcha. The line is way off. Okay, got it.
Got it?
Mm-hmm.
So we actually there are what we say, there are some methods through which we measure the performance of machine learning model, as well as the same goes for the deep learning model.
Mm-hmm.
But the major thing we look at is loss. Suppose loss is actually the difference, tells the difference how close is your model in predicting the actual value, right? Suppose the answer was the output should be 10.15, okay? And when you calculated, you got around 10.12, right? I won't say you are wrong, totally wrong, but you are close. There is a bit loss. You need to relook at the calculation, right?
Yeah.
And we do not want AI models to be 100% accurate because that will because what will happen if I just change the values of the question, then it's might possible then you might end up with 10.15 because the question was the very same, but just the values were different.
Got it.
You won't be able to generalize well, like okay, it is okay to take value of pi as 3.14 and just or take 21 by 7, 22 by 7, just basic difference, but it in the output it has a small change, right?
Yeah.
Any questions?
No.
Sure.
No, I'm okay here now. I want to try some things. I have some data, um,
Mhm.
values from something that I exported. So when I'm going into collab, I want to be able to get started to,
Okay,
input some values and
i'll
see if we
i'll
can
share the
start
link
building
with you.
something.
I'll share the link with you. The Kiran would definitely send it over to you, all right?
Mhm. Thanks.
And I'll also add a step-by-step guide which you should follow, or I would love you to explore it first. Get your hands on it, be get comfortable with it first.
Okay.
Yeah. So first try to, I'll just write down.
You gotta respell value, man. You did it wrong.
Sorry.
Value, the average
Oh,
value.
sorry. Yeah. Thanks.
Hmm.
Okay. Something like that. In deep learning, sorry, data analysis. Then we move forward, analyzed the outliers. Simply check each column values by plotting a scatter plot. Then you need to learn, you can play around with how to drop the outliers. See, outliers are just training data points which are more like a noise in the dataset. It's not
Hmm.
following the regular pattern which is present in the dataset, right?
Yep.
So, in order to take account that outliers needs to be removed, they need to be dropped or not, we
Hmm.
have to make sure that the outlier is not more than 20%. If the data is, let's say, 10 million of rows or just 1 million of rows, we are
Hmm.
fine to drop to 20,000 rows, right?
Yep.
Because that won't affect the model's performance a lot if the complexity is on the lower side. But in case we are having a data of just 1,000 rows, and if we want to train a machine learning model on that, then in that scenario, we have to think, should we drop it or not, right? Because
Hmm.
the data is already low and the outliers, number of outliers is 20% in such a small amount of data. So that means if we just keep on increasing the data, then outliers will also increase, right?
Yep.
So if there is a very small percentage in a large data set of outliers, then we can drop it simply so that the model can generalize well and outliers won't affect the training.
Okay. There's quite a few things to kind of take down here.
Sorry.
I said there's quite a few things to kind of get through here. These
Yeah.
tasks.
Then I think that's enough, right?
That's a lot. I hope I didn't get through all of
That's enough
that.
for today. I
That's
think you'll
that's
be
a
having
lot, man.
time
My
with you.
God.
It's very simple, right? What you can do is just simply just go to Gemini and
Hmm.
I want just say I want to import pandas. I want to read a CSV, and what you can do is you can just go to files, right? And you can simply upload the files whichever you want.
Hmm.
I just go and import warning. It shows warning because whenever this particular instance would be down, right? Whenever you
Hmm.
get disconnected, the data is lost. But the code would be there. You have, I'll explain that later. You can just simply import it. It will get imported. Then what you can do is just simply run df is equal to ed dot read. It is XLSX.
Yeah, you had that on the last one, right?
Yeah.
So the last one, I hope that you're sharing the last file that we had because it
Yeah,
had
it,
the.
it is in the same. It is in the same
Oh,
link.
all right, yeah, yeah. We're good. We're good. I think where I might have some challenges is doing some of the plotting. but I can try to figure it out. That'll be
Plotting
fun.
is the simplest thing. Plotting is the simplest thing. You just need to understand the value the particular column holds, right?
Yeah.
If I just say, if you're having any confusion, right? I
Mm-hmm.
would just say, okay, okay, the head is lost. Okay, I will take this example. Okay, I'll just go to ChatGPT. Just simple. I don't need not to just put my head into it. Can you suggest some plots for these columns, all numerical values? I want to capture all the possible scenarios. Okay,
Mm-hmm.
we can perform a univariate analysis, understand each variable alone, which is also called exploratory data analysis, in which you iterate one by one. I'll show you my work actually, one of my work. I have done the most detailed ED I could ever do on a data set. I just took a week on it, so from scratch. So these were the columns, right?
Mm-hmm.
There were 14 columns and there were 303 data points. And these were the columns and the values in it. Then I started printing the data types. What is the data type of each column?
Mm-hmm.
Okay, I have to add one more thing here. Data types. I have already did it. Calculate the number.
Can I
Calculate.
also manipulate the CSV or Excel file with
Yeah,
additional
you
data if
can.
I want? Okay.
Yeah, you can. You can manipulate the CSV. That's why this one create a new column, right? And
Mm-hmm.
duplicate the value from different column. You have to add one more column and you will try to duplicate the values from another column. Let's say I make another column in this one, sleep hours, and take it. I add one more column, sleep hours underscore one, right? It's another new column, and I want to replicate the value of this one. Or I can then do some pre-processing on this without losing this column. Yeah, I can convert it into minutes, something like that.
Okay.
Yeah. So this task would is for that only. If I just go ahead and look univariate, right? You can plot
Mm-hmm.
histograms, bivariate. You will take two relational columns, right?
Mm-hmm.
Sleep, like hours studied versus attendance, hours studied versus sleep hours. You can take it as time invested versus revenue, right? In your
Mm-hmm.
particular scenario, time versus budget, or you can take more than three, feature versus target. So you can do a lot of things, and it's very easy. You need not to just worry about the plotting. You just need to worry about what what you want to show to the others, show to your stakeholders, what they do want to see.
Got it.
Okay,
So it's all depending on what. Yep.
makes sense.
Mm-hmm.
I think you're good to go with this. And
Good to
then
start. Good to
yes,
start.
good to start.
Mm-hmm.
Okay, so I think it's time for me to go right now.